Welcome to EDU World Space.
Okay, so this is the circuit with the 10-volt battery reversed, right? Inserted in the opposite polarity. Okay, now we have to find the current in each branch. So let me suppose that the current in the top branch is I. Okay, so as this I goes along 3 ohm resistor, so it gets divided into the middle and the down branch. So let me consider this and this two currents be divided, I be divided into these two. Let me consider this to be I1 and this to be I2, such that I is the sum of I1 and I2. All right, yeah. So now what I can do is look at the loop here. So let me look at the upper loop here like this. Okay, so starting from the upper loop, the potential, there are two potentials that are facing uh, like not opposite to each other. So negative is uh, connected to the positive of the battery, so they combine together to give higher potential. So on the left hand side there are the batteries, that is 10 and 5. Okay, now equals to, on the right hand side I will write the potential drops. So if I begin from the 10 volt, so for the potential drop in 3 ohm, so this is 3 into I, because the I is also flowing towards the loop, along the loop. And the next is 4 ohm resistor. For this the current is I1 and again along the loop, so 4 times I1. Then the next one is 1 ohm, that also gets current I1 and again along the loop, so 1 times I1. Then finally there is a 2 ohm resistor that has current I, that is also along the loop, so plus 2I. So this should be equal to 3 equals to I plus I1. This is what we found out from the first loop. Let me write this as equation 1 here and this as equation 2. Okay, now let's look at the bottom loop. So this has only one battery of 5 volts, so on the left hand side 5. Now as you move along the battery, there is 1 ohm battery, 1 ohm resistor that has current I1, so 1 times I1. There is a 10 ohm resistor that has current I2 but against the loop, so minus 10 times I2. And there is another resistor 4 ohms that is flowing along the loop, so positive of 4I1, right? So now from this we get 1 equals to 5 minus 10, so 1 equals to I1 minus 2 times I2. So this is the third equation. Now we have three variables, I1, I2. We have three equations independent of each other. So just you have to solve these three equations, 1, 2 and 3, to get I, that is the current flowing on the top, is 1.6 amperes. Similarly, I1, the current flowing in the middle wire, that is 1.4 ampere, and I2, the current that is flowing on the bottom wire, that is 0.2 amperes. Okay, so with this we are done with part A of the question, that is we found out the current in each branch. Okay, so this is part A of the question. Now let's move on to part B. Now to find out the potential across A, B. So to do that, I can use this circuit here. So in this circuit, there is a 10 volt battery. Let me suppose that the positive has a potential of 10 and the negative terminal has a potential of 0, so that the potential difference is 10. Now this implies that the potential at A is also 10, right? Potential at A is 10, so just keep this in mind, 10 volts. Now, okay, 10 volts. Now the current that is flowing through 3 ohm resistor is I. So the potential drop would be 3 times I. So 3 times 1.6 is 4.8. So 3 ohm resistor gets a potential of 4.8 volts, right? Now since the current is flowing along this way, right? So this should be at higher potential and this should be a lower potential. Now this has a potential of 10 volts. The potential difference is 4.8. So by subtracting 10 and 4.8, we can say the potential at this point should be 5.2 volts, right? So this point also should be at a potential of 5.2 volts, isn't it? Yeah. Now again the potential drop across the 4 ohm resistor is 4 times I1, so 4 into 1.4, that is 5.6 volts. So this resistor gets 5.6 of voltage. Now since the current is flowing this way, this should be at higher potential and this should be at lower potential, and the potential difference should be 5.6. So point B should have a potential of minus 0.4, right? So that the potential difference between this point and this point becomes 5.6. So what we found out is the potential at B, the potential at B equals to minus 0.4 volts, right? I forgot a V here, V. Okay. Now if you want to find out VAV, so VAV equals to potential at A minus potential at B. So that is equal to 10 minus 0.4, and this gives me VAV equals to 10.4 volts. Wow, we are done with the solution of this problem. So thank you for watching this